Welcome, brothers. Today I'm going to walk you through a highly practical explainer on standard operating procedure number 19. We're talking about diagnosing and fixing a DAF tank that has completely stopped generating bubbles. Look, if you're a wastewater operator or a plant manager, you already know that a failing DAF system isn't just some localized headache, right? It is a massive threat to your entire plant stability. So we're going to break down exactly how to handle this crisis using the precise protocols from our SOPs. Let's get into it.
We're going to tackle this crisis step by step. We'll start with a quick refresher on the DAF technology itself, then move right into identifying the early warning signs on the floor. After that, we'll run through our 7 root cause checks, execute both emergency and permanent fixes, and finally, lock down our long-term prevention and monitoring setup. All right, Section 1, DAF technology and the incident. Let's dive right into the core mechanics of what we're actually dealing with here.
As you guys know, the beating heart of our DAF system relies on keeping that saturator pressurized at a solid 4 to 6 bar. That's what dissolves the air into the recycled water. Then, bam, when that highly pressurized water hits the pressure relief nozzles, it drops instantly to atmospheric pressure. This physical reaction releases literally millions of tiny 30 to 100 micrometer microbubbles. Honestly, these bubbles are the absolute lifesavers for our downstream biological tanks. They attach the coagulated flocks, suspended solids, and oils, drastically dropping their density and forcing them right up to the surface so the skimmer can just sweep them away.
But here's the thing, it's wild how fast it can all go wrong. When incident 19 hits, the whole tank just goes dead flat. The water turns super cloudy, kinda murky, and your skimmer? Well, it's just pushing around dirty water instead of that thick layer of sludge. Without those microbubbles doing the heavy lifting, all those untreated pollutants, the fats, oils, greases, the heavy solids, they bypass the system and head straight for our downstream biotanks. That puts your biological system in immediate red alert danger of a toxic organic overload. It'll inhibit your bugs and absolutely blow out your discharge limits.
Okay, moving to Section 2, identifying the warning signs. When you're out there on the floor, you've got to spot the symptoms of this failure immediately before it cascades into a total plant shutdown. You really need to keep your eyes and ears open out there. The symptoms are both visual and auditory. So if the effluent water is suddenly looking cloudy, or you notice the surface is completely flat without that nice thick brown or white sludge layer, yeah, you've got a problem. And pay close attention to your equipment. Is the saturator pressure gauge dipping below that crucial 4-bar mark? Is the PR pump, the pressure recycle pump, screaming at you, vibrating, or running ridiculously hot? Check the recycle flow meter, too. Is it showing a massive drop from your typical 10 to 30% design ratio? And, maybe most critically, if you don't hear that familiar, steady, hissing sound of air releasing from the nozzles, you have a major issue on your hands.
Brothers, you gotta remember this crucial rule of thumb directly from the SOP. If you spot 3 or more of these signs happening at once, you have to stop hoping it'll just magically fix itself. Seriously, do not wait for the end of your shift. You must immediately put on your detective hat and begin your root cause investigation. Which brings us right to Section 3, the 7 root cause checks. To fix this systematically, without getting totally overwhelmed by all the alarms going off, we're going to run through 7 very specific diagnostic steps. We group our first 4 checks around the mechanical side of things. Step 1, verify that the saturator is actually holding 4 to 6 bars. Give the gauge a little tap just to make sure it isn't stuck. Step 2, check your PR pump. Go grab your clamp ammeter and your infrared thermometer. You need to make sure the pump isn't burning up past 70 degrees Celsius and really listen closely for any cavitation or bearing whine. Step 3, confirm your recycle flow lines are clear and double-check that the check valves aren't jammed open or closed. Then, Step 4, if it is strictly safe to do so, inspect the nozzles themselves. You're hunting for any blockages caused by calcium buildup, rust, or hardened organics. The final 3 checks, well, they focus on the actual process. Step 5 is water quality. Pull a sample right before the nozzles into a clear glass to check for bubble release. And definitely check the temperature. Water over 30 degrees Celsius just physically cannot hold as much dissolved air. Step 6, verify your coagulant dosing. Are your dosing pumps actually running? And are they forming strong, visible flocks in the rapid mix tank? Finally, Step 7 covers your auxiliaries. Ensure your skimmer is running at the correct speed, double-check that your sludge pipes are clear, and make sure your external air compressor is delivering at least 6 bars to the saturator. Now, think about this stark difference in coagulation here. Even if your mechanics, your pump and your saturator are running absolutely perfectly, poor coagulation will leave your system totally unable to attach those microbubbles to the waste. So it's like trying to stick Velcro to water.
If your flocks are weak, you need to run a jar test immediately. You'll likely need to adjust your pH back to that optimal 6.5 to 7.5 range so you can get those large, durable flocks back in action. Okay, Section 4, Emergency and Permanent Fixes. Now that our 7 checks have told us exactly what's wrong, we've got to intervene. And that starts with immediate emergency triage.
But wait, before you touch a single wrench, let me remind you of the absolute most critical safety rule on the plant floor. Never, and I mean never, remove the nozzles or open the saturator while the PR pump is running. You are dealing with highly pressurized air and water here. Always completely depressurize the entire system and lock out your pumps before you even think about doing any maintenance. Safety first, always. So let's look at how this builds out our response strategy. We structure our response logically over time. We start with the immediate emergency actions in the first 24 hours to literally save the biological plant today. Then, we transition into the permanent mechanical fixes over the next 1 to 3 days. And finally, we implement the long-term habits and maintenance to make sure this crisis doesn't ever repeat itself.
In those first 24 hours, your goal is pure survival. You have to immediately cut your influent flow down to 50 to 70%. If you don't, you'll completely overwhelm the biotanks. Next, temporarily bump your chemical coagulants up by about 20 to 30%. Since you don't have any bubbles to float the sludge, you've got to try and force some gravity settling right there in the DAF tank. Now, if the PR pump is still partially working, maximize the bypass valve to keep some pressure up. But crucially, and listen to me here, if that pressure gauge drops below 2 bar, kill the pump immediately. Otherwise, you're going to destroy those expensive mechanical seals by running it dry. Oh, and get out there and manually vacuum the surface sludge before it sinks and clogs your bottom drains.
All right, once the immediate crisis is stabilized and your flow is managed, you've got about 1 to 3 days to execute the permanent fixes. If the nozzles were your issue, take them out and soak them in a 5 to 10% hydrochloric acid solution for a few hours. That'll dissolve the calcium right off. If the PR pump failed, rebuild it. Go ahead and replace the mechanical seals, bearings, or the impeller if it's worn down more than 10%. Make sure to clear out any compacted sludge in your recycle lines and lock in that optimized coagulant dosing based on the jar tests you just ran. Moving on to Section 5, Prevention and System Monitoring. Look, fixing the acute problem is only half the job, right? The other half is making completely sure we never have to face Incident 19 again.
To prevent this from coming back, we've got to upgrade our operating habits. You need to commit to cleaning those nozzles once a month, no exceptions. And if you haven't done it already, get a Y strainer installed on the suction line right before the PR pump. That'll catch the debris before it ever even reaches the nozzles. You should also be setting automated SCADA alarms so you're instantly alerted if the pressure dips below 3.5 bar or if your flow drops by 20%. And just from a basic management perspective, always keep 10 to 20% spare parts, like your extra nozzles, seals, and bearings, just sitting right there on the shelf ready to go. You'll thank me later.
Now, the SOP actually mandates using a specific daily monitoring log template for 7 to 14 days immediately following the incident. You're going to track saturator pressure, recycle flow, total suspended solids, and sludge depth, which, by the way, should ideally sit right between 2 and 5 centimeters. You also need to track the pump vitals. And you'll do this 3 times a shift, beginning, middle, and end. I know it sounds like a lot, but this intense monitoring is what ensures our fix is actually holding up under variable plant loads.
So how do we actually define success here? Well, we know the fix is completely successful when your pressure holds rock steady for a week, your bubbles are uniform across the entire tank with absolutely no dead zones, and your total suspended solids at the output are reduced by at least 80% compared to the input. When you see that magic 80% reduction, you know your DAF is back online protecting those biological tanks exactly like it should. So brothers, considering that losing just 1 single bar of pressure can absolutely destroy your system's efficiency, it really all comes down to vigilance. Let me ask you, are you actively tracking those small drops before they trigger a total plant crisis? Think about it. Take these SOPs, apply them on the floor, and keep your systems running strong. Thanks so much for joining me for this explainer, and stay safe out there.